Hi, this is Sushan Madhubalan. In this video, I'm going to talk about my second mini project as a part of the visualization course. In this project, the focus has mainly been on PCA and MDS. I've used the same dataset from my mini project 1, that is the credit card customer churning dataset. I have selected 10 variables from the dataset. For PCA and MDS, I have used numerical variables, whereas for parallel coordinates plot, I have also added a categorical variable. Let's start with MDS first. So as we know, MDS gives us a visual mapping of pairwise dissimilarities in the distance space of low dimensionality. Here it is 2 dimensions. For the MDS data plot, I use the Euclidean distance and visualize the data via a scatter plot. As you can see, the data belonging to similar clusters are close to each other. You can see that there's cluster 1, cluster 2, cluster 3, and cluster 4. Note that these clusters have been obtained by using k-means clustering. Then we also have the MDS variables plot. For this, I use the 1 minus absolute value of correlation distance and visualize the same using this scatter plot. Again, you can see that the dissimilar variables are far apart. For example, the transaction amount and the average open to buy are pretty far apart, right? That is because average open to buy is the credit balance left. And naturally, if the transaction amount is high, it means that the credit balance would decrease. We also have a parallel coordinates plot with 10 axes. The user can rearrange this axis and also do brushing to get the meaningful conclusions. So by rearranging axes, I mean that a person can uh, move these axes to any point of their choice to get a more better understanding of how these variables are related to each other. For this particular parallel coordinates plot, I have used numerical variables as well as a categorical variable. As you can see, contacts count is a categorical variable. So in this graph, I've also implemented the brushing, which is a technique in which you can uh, choose a particular part of the graph and try to understand the data points in that particular part of the graph. So note that each of these lines is one data point. So let's say one of the data points starts from here. So this is the credit limit, this is the customer's age, and this goes on to average utilization ratio and so on. Also, we can see that each of these data points or these lines have a specific color. The color comes from the k-means clustering, as we had seen even in this one in MDS data plot. So regarding brushing, let's try to let's try to focus on the customers who have a high average open to buy. So let's say we want to see this particular part of the customer base. So as you can see, high average open to buy also kind of corresponds to a high credit limit. So average open to buy is the amount, the balance or the credit that a person has in a month. So let's say the um credit card offers $1,000 per month of expenditure, and a person spends only $200. So $800 would be the average open to buy for that month, and that is averaged over the entire year. So we can see that high average open to buy is also a high average credit limit, and similarly, it also kind of it also talks about this transaction count that it's a little bit lower, and the utilization ratio also is very low, which is intuitive, right? Because although the credit limit is high, the average open to buy was also high, which means the utilization was very low. Next, if we shift this to a low average open to buy, you can see that the credit limit is again low, and so has everything else. Like it literally tracks every data point, right? So talking about these two axes, credit limit and average open to buy, we are seeing that they are very close to each other, right? And as you can see, even in the MDS variables plot, they are very close to each other, which means they are not very dissimilar, or they are very similar, right? So now we can shift to PCA. Under this, I implemented Scree Plot, Scatterplot matrix, and the biplot. As we know, the goal of PCA is to explain most of the variability of the data within a small number of variables than the original dataset. The PCA finds the low dimensional representation of the dataset that contains much of the variance as possible. Each of these bars represents one principal component, and on the y-axis we have the variance ratio. As you can see, this line contains the sum of the variance ratio from principal component 0 all the way till 9. So as you can see that the line, uh, it kind of, it touches 1, right? So all the principal components together have a sum of variance ratio of 1. So the user can select an intrinsic dimensionality index. So as you can see, you can click on one of the bars to select the intrinsic dimensionality of our choice. And that would plot a scatterplot matrix and would also display a table of the top 4 attributes with the highest uh, SSL, which is the sum of squared loadings on those PCs. So um, let's say we choose a value of, we want an intrinsic dimensionality of 5. So, so we have chosen an intrinsic dimensionality index of 5. So we can see that there is a table. And these are the top four attributes with the highest sum of squared loadings. And these are their respective loadings. And these 4 attributes are also used to plot a scatterplot matrix. Which is this, right? So it's a 4 by 4 scatterplot matrix, and you can see that each of these cells uh, corresponds to one graph. So if you talk about this is the average utilization ratio versus the open to buy, and so on. And even here we can see that each of the points have their colors according to the cluster that they belong to, as per the k-means clustering that has been done previously. So by changing the intrinsic dimensionality index, one can plot the scatterplot matrix as well as get an idea of what are the top 4 attributes. Also, as a part of PCA, I've also plotted the biplot. Now, the biplot, this contains all the 150 data points as a scatterplot, and it also contains the various variables. So as the angle between two of the variables decreases, it means that they're positively correlated. And if the angle is more, it means that they're negatively correlated. So to take an example, as we can see that the total transaction amount, total transaction count, and all of these related to count and transaction amounts are very close to each other. The angle is it's lower, right? It's small angle, which means they're all positively correlated. Whereas if you take, let's say, average utilization ratio and the average open to buy, the angle is huge, right? And they're far apart. So it means that they are negatively correlated. Naturally, if you have uh, a high average open to buy, which means you have a high credit balance, it also means that the utilization is low, right? So that's how it explains the negative correlation. Also, for this particular biplot, I had to scale the uh, data points down in the range -1 to +1. This ensures that the lines, these lines, as well as the points, all of them are clearly visible on a single graph under the same scale. With this, I would like to conclude this video about my second mini project as a part of the visualization course. Thank you.